Hi, I'm Robert,
And I'm Daniel.
and we're here with Launch Team Robotics 6352 to help you get your robotics merit badge done. Hi, it's Robert again, and I'm going to be going over requirement 1A, safety, where you have to do each of the following of these. You have to explain to your counselor the most likely hazards that you may encounter while working with robots, and what you should do to anticipate, mitigate, and prevent and respond to these hazards. You're also going to need to describe the appropriate safety gear and clothing that should be used when working with the robots. So I'm going to be going over that right now. Some hazards that can be found when you're working or trying to build robots is things like sharp metals, like this. There's some sharp sides on this. Broke robots, moving gears, hot motors, or processors, or any types of projectiles that can be flying around the workspace. Also, a nice thing to have around would be any type of first aid kit to help with anything that may go wrong.
This is Daniel, and I'm here to talk to you about requirement 1B. Discuss first aid and prevention for the types of injuries that could occur while participating in robotics activities and competitions, including cuts, eye injuries, and burns, chemical or heat. For cuts and scrapes, you'll want to wash, clean, and cover them, as is usual, and stand clear of the robot in motion. Finish edges and wear gloves if needed. For smashed fingers, ice, elevate, and exercise. Keep hands clear of gears and belts, and cover the gear train if able. Do not use gloves. Electrocution. Stop connection. If serious injury or heart problems occur, call 911. Double-check all connections before connecting the battery. Never touch a live wire or allow batteries to short circuit. Burns. If minor, apply cold water. If major, call 911. Do not allow motors to strain or jam. Do not touch motors or processors while or after the robot is in use. And do not allow circuits to short circuit. If you are hit with an object, if it's minor, allow rest and apply ice pack if needed. If it's major, call 911. For requirement 2A, the kinds of things robots can do and how they are best used today. So robots can be used for a number of things, just a few being jobs too menial, dangerous, or delicate for humans to do, such as car assembly, welding, food packaging, to explore space even, or in the ocean, and to do precise surgeries and medicine creation.
I'm going to be going over the different types of robots: remote control, autonomous, and teleop. I'm going to start off with remote controlled. Remote controlled robots, your human is essentially in control of the robot. You're often in close proximity of the robot, which means you're really close to it. Your controls are directly engineered and wired to your specific robot. Our second kind is teleoperated, and human is in control for majority of the time. They're often much farther away. They necessitate the use of telemetry, and that is the collection of data and transmitting of instructions from a long distance. Sensors are important, but you can also use something called dead reckoning. And our third type of robot is autonomous. Autonomous, those are human programs. You let the robot do the task on their own. There's no intervention by humans, and you're just there to calibrate the robot and program it to do something. Sensors are very crucial to this.
And now for requirement 2C. 3 different methods robots can use to move themselves other than wheels or tracks. Describe when it would be appropriate to use each method. So there are 3 main methods here: leg or arm based, robot humanoids that have more height, more reach, more compatibility. However, they're top heavy, they are difficult to balance, and they're not very good on uneven surfaces. There are rotor-based drones. They can get altitude, they're lightweight, they're fast, but they're very noisy and dangerous if they fall. They also have to be small. Lastly, there are soft robots. They're flexible, low power, versatile, but they need further research before they can be proven to be useful. For requirement 3A, the human-robot interface. So anthropomorphic, human-like, form factor, and similar proportions allow it to interact in spaces where a human easily could on the International Space Station.
Manipulation. And human-shaped tendons and hands are able to use tools and operate items or controls that humans normally would maintain with an accurate level of dexterity and grip, even in microgravity. But robots with these types of tools and operation levels can do this as well.
C. Sensors. Encoders and motors to measure and control arms and legs, vision processing and camera stream back to NASA. Gyroscopes and accelerators to measure orientation and large body movement.
Mobility or locomotion. Locomotion is really just how the robot gets from place to place, how it moves in its environment, and how things can be achieved, whether it be with their legs, with their arms, like on humanoid robots, claws, anything like that. That would be considered locomotion. Our final field of robotics is programming. Programming is how you talk to your robot or how you make it do things. You can program it to learn or adapt to its environment, and you can control it to move with programming. You can control it to do anything with programming, and that this is going to be the main thing that your robot will run on. For our next requirement 4 will need some audience participation. Requirement 4 is to design, build, program, and test your own robot. With your counselor's approval, of course, you will need to choose a task for your robot or robotic system that you will plan to build. You will document this information in a notebook. When you design your robot should use sensors and programming and have at least 2 degrees of freedom. Document your designs in your engineering notebook again. Now you are going to build your robot off of your original design, and you will need it to accomplish the task that you originally chose for your requirement 4A. Once you get done with all of these things, discuss with your counselor the programming options available for your robot, then do either the first option or the second option that I'm about to say. For your first option, you can program your robot to perform the task you chose for your robot in 4A. Include a sample of your program source code in your robot engineering notebook once again. Or you can prepare a flowchart of the desired steps in 4A. Include procedures that show activities based on sensor inputs. Place this in your robot engineering notebook as well. Next, you're going to need to test your robot and record the results in your robot engineering notebook again. You can include suggestions in there on how you can improve your robot, and as well as pictures and sketches of your finished robot. This is all part of an engineering process that you can do to help make your robot better. And of course, you'll need to do this on your own, as this is an activity that you can do given some information in education. For requirement 5, you will need to demonstrate your counselor the robot that you just built in requirement 4. You're going to share your robot engineering notebook with your counselor and talk about how well your robot accomplished these other things. Talk about the improvements you could have made that you could have recorded in your notebook, what you can do to make it better, and what you learned in this whole process. Requirement 6 is all about competitions. However, you only have to do one of the following. You could do 6A, where you could attend a robotics competition and report to your robotics counselor what you saw, what you learned about the competition, and how teams are organized and managed. You can tell what you liked about the competition, maybe some things you would have liked to see there, how you think they work together, and how, anything that you thought about it. Or you could do 6B. You could learn about you only need to learn about 3 youth robotics competitions. Tell your counselor about these, including the type of competition that it is, time commitment, how old the participants need to be, and how many teams are involved, whether they be only 2 or many. Some youth robotics competition programs that I know of are BEST, B.E.S.T, acronym, is a robotics design contest. There's FIRST robotics competitions, which is what Launch Team is a part of. VEX hosts their own robotics challenges, and there's many more that you can look up. Now for our final requirement for the robotics merit badge. This one is all about careers. You will have to name 3 career opportunities that involve robotics in any way. Pick one and find out the education that you need, the training and experience experience that you will need to be involved with these jobs or careers. Discuss with your counselor and explain why one of these professions might interest you or all of them. As for all of the videos that you've been watching, remember that these videos are here to help you guide you through the process of this robotics merit badge. You will still have to participate and do things and build your own robot and talk to your merit badge counselor. Remember to get a blue card so you can sign these things off, and I hope you enjoyed. Have fun.